surprising revelation made by the James Webb Space Telescope uncovered what appeared to be urban illumination in space, located 7 trillion miles from Earth. This significant discovery has ignited curiosity about the potential for extraterrestrial existence. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the origin of these city-like lights on Proxima Centauri b? Could this indicate the presence of life beyond our planet? Join us as we explore how the James Webb Space Telescope identified these unprecedented phenomena in space. For years, scientists and the general public have speculated and investigated the possibility of life beyond our solar system. Any evidence supporting this cosmic dream has been welcomed with enthusiasm. Recently, mainstream scientists were astonished when compelling evidence of living entities existing in space was observed by the James Webb Space Telescope. While surveying space and transmitting data back to Earth, the James Webb Space Telescope detected peculiar city-like lights shimmering from the exoplanet Proxima Centauri b. These lights, as their name suggests, seem to illuminate a distant metropolis. The prospect of an alien city existing on this star has left researchers in awe. They are baffled, as this could be the presence they've all been anticipating. If this proves to be true, as many believe it might, it signifies that intelligent living beings are constructing civilizations unknown to humanity in outer space, and we are just beginning to uncover them. Investigating the city lights found 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have been shining in space, awaiting humanity to develop the technology necessary to detect them. David Kipping, a space expert from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as intriguing. He said so because this star system, closest to us, exhibits fluctuating warming patterns that differ from those of other planets. Typical rocky planets are known to absorb sunlight and emit infrared radiation, but not Proxima b. Its infrared characteristics are very different from those of its host star Proxima Centauri. This suggests a significant observation of Proxima b by the James Webb Space Telescope, JWST, which is capable of detecting infrared frequencies. The distinct heat signature of Proxima b will play a crucial role in uncovering the planet's atmospheric mysteries. Thanks to the latest technology in infrared imaging, researchers plan to use the JWST to uncover the secrets of its atmosphere. They also expect to use the telescope to assess the possibilities of life on this exoplanet. The James Webb Space Telescope has infrared sensitivity that can investigate what happens on Proxima Centauri b's nighttime side, capturing even the faintest beams of light in the vast darkness. This is typically a challenge for space telescopes, but not for the JWST, which can detect even the smallest light emissions from space. It is the perfect tool to verify if the rumors about city lights on Proxima's night side are true. Any artificial lighting in the universe can be detected by the telescope, as long as it falls within a frequency band 1,000 times smaller than starlight. Proxima b has an intriguing connection between its celestial elements and surface features. The daytime side of the exoplanet contains a vast number of solar panels that harness the radiant energy from the star. Its spectral edge also reflects incoming light beams. At the same time, when Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods similar to those on Earth. During the day, it encounters high solar heat, while at night it cools down. The planet is known to have fluctuating temperatures determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be very rapid and extreme. Without the moderating effect of atmospheric gases, the temperature on the day side will be very hot, and the night side will plunge into cold darkness. The degree of temperature variation is a major subject for astronomers to unravel, providing a deeper understanding of Proxima's atmospheric composition. With the JWST's unparalleled infrared imaging capabilities, it will enable efficient analysis of the planet's thermal emissions to provide valuable information about its atmospheric properties. Curiously, the orbit of the James Webb Space Telescope around Earth aligns with Proxima b's orbital period, allowing for thorough observations of its day and night periods within just 11.2 Earth days. Since Proxima b does indeed have an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can support life. Key signs of life include the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it would suggest habitable conditions. The process of effectively determining this requires researchers to be careful as they capture and analyze light beams traveling through the planet's atmosphere. This is a challenging task for future telescopes to undertake. Even with the JWST's extraordinary abilities for describing planetary atmospheres, the James Webb Space Telescope, while powerful, does not have absolute capabilities and can only peer at a few of the closest exoplanets to Earth. To conduct intensive atmospheric examinations, astronomers are now looking toward ground-based observatories like the Extremely Large Telescope, ELT, which is planned to begin operations in 2028. The ELT is set to probe the atmospheric structure of faraway exoplanets and will produce data that offers in-depth insights into their habitability. NASA researchers and the public eagerly await the development of future space telescopes like these. Until then, the James Webb Space Telescope remains an essential tool in our quest to uncover the secrets of distant exoplanets. Despite its current limitations, the JWST has the potential to provide profound insights that could revolutionize our understanding of exoplanetary exploration. Researchers have set a goal for future space telescopes to reduce the brightness coming from a planet's parent star, enabling astronomers to better observe the reflected light from the planet itself. They plan to achieve this by utilizing internal masks or large external spacecraft shaped like parasols, similar to shielding your eyes with your hand to better see an object under sunlight. Dimming the overwhelming brightness from a host star will allow upcoming telescopes to concentrate on faint reflections from distant exoplanets, permitting a more detailed examination of their atmospheres and the potential for supporting life. However, this task presents its own set of challenges. Scientists must distinguish between gases generated by biological processes and those arising from geological phenomena, such as volcanic activity. Astronomers remain determined to understand the properties of exoplanets more thoroughly in order to recognize genuine signs of life and differentiate them from misleading indicators. The James Webb Space Telescope serves as a preview of scientific breakthroughs in the study of exoplanets, offering a glimpse into the astonishing discoveries yet to come. As we expand our comprehension of the cosmos, the mission carries on. As our exploration of the universe advances, we become increasingly equipped to grasp the intricate mechanisms of the cosmos and our unique place within it. After scanning countless planets in space, researchers have not yet located one that supports life. Despite decades of combing the universe for signs of living organisms, the quest continues. Are we solitary inhabitants of the universe? For centuries, humans have questioned whether we are alone in existence. This enduring curiosity still resonates today. Even now, researchers rely on the James Webb Space Telescope in orbit, striving to detect alien societies concealed among the stars, while analyzing numerous planetary bodies for life-related indicators. At the same time, a widely circulated theory has recently emerged, proposing that certain extraterrestrials might indeed exist out there in the galaxy, awaiting humanity's discovery. To address this enduring question, two American astronomers, Jill Tarter and Thomas Pearson, initiated a project in 1984 called the Search for Extraterrestrial Intelligence, SETI. Known today as the SETI Institute, it is a non-profit organization that aims to analyze astronomical transmissions in order to identify radio signals from space. The focus on radio waves stems from their capacity to traverse vast distances without being scattered or absorbed, unlike many other forms of radiation. Thanks to this attribute, radio signals are more likely to be detected by the 42 radio dishes that make up the Allen Telescope Array, located in California's Cascade Mountains. Although the SETI Institute has meticulously scanned for radio signals possibly emitted by alien civilizations, no confirmed transmissions have been received in over 3 decades. Nevertheless, Jill Tarter remains optimistic, expressing her desire to empower Earth's inhabitants to take part in the ultimate search for intelligent life beyond our world. All of this work continued until recent NASA reports revealed that the James Webb Space Telescope may have identified urban lighting on a planet near Earth. The JWST represents humanity's most powerful tool to unlock the mysteries of the cosmos. Launched in December 2020, it stands as the most advanced infrared observatory ever constructed. Outfitted with state-of-the-art optical systems, the James Webb Space Telescope can peer through cosmic dust to reveal hidden aspects of the universe. Its primary objective is to explore deep space in search of the earliest galaxies and stars that formed billions of years ago. Named after James E. Webb, a visionary NASA leader who played a key role in space exploration and the Apollo moon missions, the telescope is equipped with a specialized suite of instruments working in harmony to deliver unmatched cosmic insights. These include a near-infrared camera, NIR-CAM, a near-infrared spectrograph, NIR-SPEC, a mid-infrared instrument, MIRI, and a fine guidance sensor, FGS, which ensures the telescope maintains its exact position while observing distant targets. The enormous mirror of the James Webb Space Telescope, made up of 18 hexagonal sections, was meticulously engineered to capture faint light from the oldest galaxies. Built to function at extremely low temperatures, the telescope is able to detect even the weakest thermal signals from remote celestial bodies. Since its deployment, the JWST has captured remarkable images and transmitted groundbreaking data, leading to numerous discoveries about galaxies, exoplanets, and stellar phenomena. While its main focus has been on these subjects, the unexpected observation of lights resembling those of a city has caused experts to rethink the potential for extraterrestrial civilizations. The detection of apparent city lights on Proxima Centauri b has astonished scientists, and investigations are still underway. The telescope's ability to examine the deepest corners of space is bringing humanity ever closer to answering one of the most profound questions of all. Are we alone in the universe? As researchers continue their analysis of these strange and unprecedented lights on Proxima Centauri b, numerous questions arise regarding the next steps in solving the enigma of alien life. A central mystery is whether these lights are artificial in origin, since the regularity and intensity of the emissions suggest they may not stem from natural causes. Some theorists propose these lights could be evidence of intelligent life forms with technological capabilities, or even naturally occurring luminous organisms producing light in unknown ways. The idea that such structured lighting could come from a planet so distant challenges many existing beliefs about the boundaries of life in space. Yet, there remains the possibility that what appears to be artificial lighting is actually caused by unusual natural activity not yet fully understood. Certain scientists suggest that these visible patterns might result from rare atmospheric interactions, potentially tied to the planet's turbulent climate or to energy from its star. Magnetic interactions, radiation belts, and complex chemical processes in Proxima Centauri b's atmosphere might generate effects that resemble artificial lighting to the telescope sensors. However, this theory remains debated and requires further investigation. To resolve this, scientists will focus future efforts on tracking how the light emissions evolve over time and whether they demonstrate repetitive or structured behaviors. The James Webb Space Telescope's capacity for ongoing observation makes it ideally suited for collecting data on whether these emissions are stable or fluctuate in a way that aligns with technology-based activity, like electricity grids or manufactured infrastructure. Continued monitoring is essential and may eventually reveal key evidence to unravel this mystery. In parallel, as scientific tools and techniques improve, researchers anticipate deploying even more refined instruments for studying exoplanets. Future space missions and next-generation observatories, such as the Extremely Large Telescope, ELT, will offer new abilities to identify planetary signals and retrieve data that complements the JWST's discoveries. Collectively, these platforms will create a collaborative system of cosmic exploration that could confirm extraterrestrial life, or at least enhance our knowledge of alien worlds and their potential to support life. As the search for life outside Earth moves forward, the idea of detecting intelligent beings through the analysis of distant planetary lighting opens a new chapter in scientific exploration. Although humanity has yet to verify alien existence, every unusual discovery, whether a strange signal, an unexplained light source, or a mysterious anomaly, draws us closer to the answer. The consequences of discovering life beyond Earth would be immense, impacting science, philosophy, and society. Realizing we are not alone could fundamentally transform our understanding of our place in the cosmos. Moreover, confirming the presence of advanced civilizations might usher in a new era of human history, one defined by the potential for sharing wisdom, culture, and perhaps even interstellar technology.